straw ballot results for NFPA 70, the National Electrical Code, are now posted. It is important to remember that these results are preliminary and subject to change. The Technical Correlating Committee, or TCC, has not yet reviewed these results. Therefore, the current straw ballot outcomes do not represent the final actions. Review the straw ballot results with the understanding that modifications are possible after the TCC review. This information is crucial for anyone involved in electrical work, code enforcement, or standards development. Awareness of the code development process helps ensure compliance and promotes electrical safety. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation and inspection to protect people and property from hazards arising from the use of electricity. It is updated every 3 years. These updates reflect the latest advancements in electrical technology, address emerging safety concerns, and incorporate feedback from stakeholders across the electrical industry. The code development process involves several key steps. Firstly, proposals are submitted by individuals, organizations, and code-making panels to modify or add to the existing code. Secondly, these proposals are reviewed by code-making panels, or CMPs, which are comprised of experts in various fields of electrical work. Thirdly, the CMP then develop first revisions based on the proposals and public comments. Fourthly, a second draft report is created. Fifthly, a standards council reviews the changes and then issues the new code. The straw ballot is an early stage in the code revision cycle. It provides an initial indication of the direction that the code-making panels are leaning towards on various proposed changes. The TCC plays a vital role in ensuring the overall coherence and consistency of the NEC. Its review helps to resolve any conflicts between different code sections and ensures that the code is technically sound and enforceable. Code-making Panel 6, or CMP-6, is responsible for Article 250, which covers grounding and bonding. Grounding and bonding are essential for electrical safety. They provide a low impedance path for fault current to return to the source, which helps to trip over current protection devices like circuit breakers and fuses. This, in turn, minimizes the risk of electrical shock and fire. Article 250 outlines the requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. These requirements are designed to ensure that electrical systems are properly grounded and bonded, regardless of the type of building or occupancy. Grounding electrode systems typically consist of one or more grounding electrodes that are connected to the earth. Common types of grounding electrodes include metal underground water pipes, ground rods, and concrete encased electrodes. Equipment grounding conductors provide a path for fault current to return to the source from non-current carrying metal parts of electrical equipment. Bonding jumpers are used to connect different metal parts of an electrical system together, ensuring that they are all at the same potential. Proper grounding and bonding are critical for the safe operation of electrical systems. Failure to properly ground and bond can result in electrical shock, fire, and equipment damage. It's very important to follow the requirements outlined in Article 250 of the NEC. Changes to Article 250 are frequently proposed during the code revision cycle. These changes may address new technologies, clarify existing requirements, or improve the overall safety of electrical systems. Understanding the code development process, including the straw ballot results and the role of the TCC, is essential for staying up to date with the latest changes to the NEC. This knowledge helps to ensure compliance with the code and promotes electrical safety. The NEC contains many articles and tables. For example, Article 210 covers branch circuits, while Article 220 covers branch circuit feeder and service calculations. Table 310.16 provides ampacity ratings for conductors. These are just a few examples of the many important provisions contained in the NEC. When working with electrical systems, it is always important to consult the latest edition of the NEC and follow all applicable requirements. This helps to ensure the safety of people and property. The NEC is not intended to be a design manual. It is a safety standard that outlines the minimum requirements for safe electrical installations. Licensed electrical contractors are responsible for designing and installing electrical systems that meet the requirements of the NEC. Electrical engineers often design electrical systems for larger commercial and industrial facilities. They must have a thorough understanding of the NEC and other applicable codes and standards. Electrical inspectors are responsible for enforcing the NEC. They inspect electrical installations to ensure that they comply with the code. Electrical inspectors play a vital role in ensuring electrical safety. Many jurisdictions require electricians to be licensed. Licensing typically requires passing an examination and completing a certain amount of on-the-job training. Licensed electricians have demonstrated that they have the knowledge and skills necessary to safely install and maintain electrical systems. Continuing education is often required to maintain an electrical license. This ensures that electricians stay up to date with the latest changes to the NEC and other applicable codes and standards. Apprenticeships are a common way to enter the electrical trade. Apprentices work under the supervision of licensed electricians and receive on-the-job training. Apprenticeships typically last for 4 to 5 years. Upon completion of an apprenticeship, an individual may be eligible to take the licensing examination. The NEC is constantly evolving to reflect changes in technology and address emerging safety concerns. Staying up to date with the latest edition of the NEC is essential for anyone involved in the electrical industry. The NEC is published by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops and publishes codes and standards related to fire safety and electrical safety. The NFPA also provides training and education programs on fire safety and electrical safety. The NEC is adopted by many jurisdictions throughout the United States and around the world. It is the most widely used electrical code in the world. The NEC is a valuable resource for anyone who works with electrical systems. It provides a comprehensive set of requirements for safe electrical installations. By following the requirements of the NEC, it is possible to minimize the risk of electrical shock, fire, and equipment damage. Remember to always consult the latest edition of the NEC. In addition to the NEC, there are other codes and standards that may be applicable to electrical installations. These include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable codes and standards before beginning any electrical work. Electrical safety is everyone's responsibility. By following safe work practices and complying with the requirements of the NEC and other applicable codes and standards, it is possible to create a safe electrical environment. Never work on electrical equipment unless you are properly trained and qualified. Always de-energize electrical equipment before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. Follow lockout/tagout procedures to prevent accidental energization of electrical equipment. Report any electrical hazards to your supervisor or to the appropriate authorities. Electrical safety is a critical aspect of any electrical work. Neglecting it can lead to serious injuries or even fatalities. It's imperative to prioritize safety in every electrical task, no matter how small or routine it may seem. Before commencing any electrical work, it's essential to conduct a thorough risk assessment to identify potential hazards. This assessment should consider factors such as the voltage level, the condition of the equipment, and the presence of any environmental hazards. Once the hazards have been identified, appropriate control measures should be implemented to mitigate the risks. These measures may include energizing the equipment, using insulated tools, wearing personal protective equipment, and establishing a safe work zone. Proper training is crucial for ensuring electrical safety. Only qualified and trained personnel should be allowed to perform electrical work. Training should cover topics such as electrical theory, safe work practices, the use of personal protective equipment, and lockout/tagout procedures. Regular refresher training is also important to keep workers up to date on the latest safety procedures and regulations. Personal protective equipment, or PPE, plays a vital role in protecting workers from electrical hazards. PPE may include items such as insulated gloves, safety glasses, arc-rated clothing, and insulated footwear. The type of PPE required will depend on the specific hazards present in a work environment. It's essential to inspect PPE before each use to ensure that it is in good condition and that it provides adequate protection. Lockout/tagout procedures are designed to prevent the accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the equipment from all sources of energy and placing a lock and tag on the disconnecting device to prevent it from being re-energized. Lockout/tagout procedures should be followed whenever electrical equipment is being worked on. Branding and bonding are essential for electrical safety. Branding provides a path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock. Bonding connects all metal parts of an electrical system together, ensuring that they are at the same potential and minimizing the risk of electrical shock. Regular inspections and maintenance are crucial for ensuring the continued safety of electrical systems. Inspections should be performed by qualified personnel and should cover all aspects of the electrical system, including wiring, equipment, and protective devices. Maintenance should be performed on a regular basis to prevent equipment failures and ensure that the system is operating safely. Electrical codes and standards, such as the NEC, provide detailed requirements for safe electrical installations. These codes and standards are developed by experts in the electrical industry and are based on years of experience and research. Compliance with electrical codes and standards is essential for ensuring electrical safety. Electrical safety is a continuous process that requires ongoing attention and effort. By following safe work practices, using appropriate PPE, and complying with electrical codes and standards, it is possible to create a safe electrical environment for everyone. Remember to prioritize electrical safety in every task and to never take shortcuts that could compromise safety. Always consult with qualified professionals if you have any questions or concerns about electrical safety. Electrical hazards can be deadly. Taking the necessary precautions to protect yourself and others from these hazards is essential. Electrical safety is not just a set of rules and regulations, it is a way of life. By making electrical safety a priority, you can help to prevent accidents and injuries and create a safer world for everyone. The information provided in the straw ballot results and throughout the NEC is intended to provide guidance on safe electrical practices. However, it is not a substitute for professional judgment and expertise. Always consult with qualified professionals before making any decisions about electrical installations or repairs. Stay informed about the latest developments in electrical safety and continue to learn and improve your knowledge and skills. Electrical safety is a shared responsibility. By working together, we can create a safer electrical environment for everyone. Remember, electrical safety is not a destination, it is a journey. Continue to learn, adapt, and improve your practices to ensure that you are always providing the safest possible electrical environment. The complexity of electrical systems often requires a deep understanding of electrical theory and practical skills. The combination of knowledge and skill is what makes a qualified electrical professional. With continuous learning and dedication to safety, electrical professionals can play a critical role in preventing accidents and ensuring the reliable operation of electrical systems. Embrace continuous learning, stay committed to safety, and be a champion for electrical safety in your community.